Hey guys, I just wanted to do a quick video talking about um, phase shift and vertical shift. So the first thing that I wanted to look at is just the regular parabola function, which if you remember is y equals x squared. Now remember, there were two different things that we could do to this function, right? We could shift it up and down and left and right. And remember, if we wanted to shift it, for example, to the right, I don't know, 2 units or something like that. Oops. So this is 2 right here. Like this. If we wanted to shift it to the right 2 units, we would go y equals x minus 2 squared. Y'all remember that, right? The minus 2 shifts you to the right. When it's negative, it shifts you to the right. If I wanted to shift it, say, down 2 units, then you could do something like y equals x squared minus 2. But notice now the minus 2 is on the outside. So this is negative 2. All right? So you remember, you subtract, minus on the inside will get you to the right 2 units. Obviously, plus on the inside will get you to the left. Minus 2 units on the outside gets you down. And if I wanted to go up 2 units, y equals x squared plus 2, for example. Does that make sense? So that was parabolas. Notice shifting goes the exact same way for sine functions. So let's go into the regular sine function. Let's just remember real quick. This is not perfect, but you get the idea. Remember, we bounce between 1 and negative 1. And for y equals sine of x, let's just remember you start at 0, 0. Then you're going to hit the point, we got pi over 2, pi, 3 pi over 2, and 2 pi. Right, you remember that? So we've got all those points, and remember, you start at 0, 0. Pi over 2, you're going to go up to 1. Just fill in kind of like this. If you don't remember, make sure that you watch the video on how to, on amplitude and period, because it kind of goes through how to graph these things. After that, and I mean, obviously, it continues to go both directions. Now that you have that, let's think, okay, what if I wanted to shift this down a unit? Well, if I wanted to go down 1 unit, this is y equals sine of x minus 1 on the outside. Because just like the x squared, where we could shift up and down by adding to the outside of my function, do the exact same thing with the sine function. So what in the world would this look like? Well, let's think about it. We bounce between 1 and negative 1. So if I shift, all of this now comes down by 1 unit. Then I'm actually going to be bumping between 0 and negative 2. Why? Because now my midline goes from being, so let's just remember, the midline is what's halfway between where you're oscillating from. I'm oscillating from negative 1 to 1. The midline goes from being here to being here at negative 1. So let's make this our new midline. Okay. Now, just like we would start. So we started on midline at 0. We're going to do the same thing here. So this will be our first point. Just remember, all right, we still got pi over 2, pi, 3 pi over 2, and 2 pi. And now what we're going to do is we're going to take this whole thing and shift it down here. So now at pi over 2, we went up 1. So from pi over 2, we're going to go up 1 on the midline. Hit right there. At pi, we're on the midline. At 3 pi over 2, we're 1 below the midline. And at 2 pi, we're on the midline. So this is a function. And we shifted it down 1. All right, so that's our vertical shift. This is called a and it works just like the x squared functions. Now, what if we wanted to shift right or left? All right, so vertical shift, obviously shifting up or down. What do we want to shift right or left? Well, just like in the x squared function, we're going to need to add inside of the function. If you think about, you can think about it like this. Remember, you have y equals x minus h squared plus k, right? Well, think about it like y equals sine of x minus h plus k. Remember, h is my left to right shifts, k is my up and down shifts. All right, so let's do it. Let's say I wanted to shift everything by pi over 2. All right, I want to shift everything to the right by pi over 2. Well, let me bring this up just a little bit. That's going to be, this will be y equals sine of x minus pi over 2. Because now my h, my horizontal shift, or what we call phase shift, is going to be going left or right. All right, so what does this mean for us? Well, let's just look at some values real quick. Obviously, we're still going to be oscillating between 1 and -1 in this case, because notice there is no vertical shift. The amplitude is 1. This is going to be a regular period, so we don't have to deal with all that. So let's take a look. What in the world would this thing look like? Well, let's think about it. We got pi over 2, right? Pi, 3 pi over 2, 2 pi. And I'm going to go one step further. I'm going to put 5 pi over 2 on here too. I'll explain why in a minute. Now let's think about it. On our regular sine graph, start at 0, 0, right? But we phase shifted by pi over 2. In other words, we have shifted to the right. Remember, subtraction means going to the right when we're shifting vertically. We've subtracted or we shifted by pi over 2. So then you take this point where we started at 0, 0 is now actually going to be at pi over 2. So then we just fill in the rest. So now at pi, we're going to be at 1. 3 pi over 2, we're going to be at 0. 2 pi, we're going to be at -1. 5 pi, we're going to be at 5 pi over 2, we're going to be at 0 on the midline. And then obviously, we could go backwards if we wanted to. It's going to do this. But the point of the matter, though, is that instead of starting at 0, we have now started where? Pi over 2. Why? Because we phase shifted by pi over 2. And that's the basics.